Good day, students. I welcome you once again to this class as we continue the topic on descriptive statistics. Today we are looking at presentation of data, and we have three ways of data presentation. We have tabular, which is by table, frequency table. We also have numerical method, where we have the measure of central tendency and the likes. So we also have the graphical method of data presentation. But today we are looking at presentation of data using table. So let's start by discussing the principal aim of any statistical inquiry, which is to enable us to understand and describe the population of interest. And we have examples stated here. For example, a farm survey, which is aimed to estimate current crop output and evaluating the impact of various government policies. Also, a researcher may be interested in studying the number of infants with high level of bilirubin in a specific geographical area over the past several years. So he or she must gather data from various doctors, hospitals, or health departments. Therefore, the first task of a statistician is that he needs to organize the data, present the data in such a way that some characteristics, salient characteristics, can be easily observed. And this can be presented using these three methods that I've mentioned: tabular, graphical, or numerical. So today we are considering the tabular method. Now let's see, for example, suppose in your enumeration area here, 35 farming households were sampled, and the weight of heads of the household in kilogram to the nearest whole number as obtained from the feed as shown in the figure as presented in the course material. So we have the first head of the household weight to be 70 kg, the next person 66 kg, 60 kg, and so on and so forth. If you look at the number, we have 35 observations, which represents the weight of the head of households in kilogram to the nearest whole number. So these observations of the data set are what we refer to as the raw data. The data as obtained from the feed. So raw data. And with the data in this form, you can only get little or no information from this. For example, you can't easily tell which farmer has the highest weight. You have to scan through one after the other. Easily you can't tell what is the the number of the weight that has the most occurrence, which is mode, and which one is the mean. Which value represents these 35 heads of household. So now the first possible thing that we can do is to put this data in what we call an array. An array is the arrangement of the values in ascending or descending order of magnitude. So For example, if we put the data in ascending array, we have the following results as we have it here. You will see that we have the observations arranged from the lowest value to the highest value. That is 52 here is the smallest observation, 76 is the highest observation. So from this we can tell which observation is the least and which one is the highest. So we have the value 52 kg as the least and 76 as the highest observation. Now from there we can derive what we call a frequency distribution table. Now we have 35 observation here. We can present this as it is in ungrouped distribution, and if we do that, then we have all the observations listed from 52, 53, 55. There is no 54. So now, how many 52 do we have? We have one. We have 53 appearing once, 55 also appear once there. So now, if you look at it here, we have only 52, 153, there is no 54. We have 55 occur once, then 57, then 59 appeared twice. So, and that is what we recorded here. 59 appeared twice, 60 appeared 4 times, and so on and so forth. So from this table, you will see the frequency of each observation as appeared in that data. Now note that this classification tells us more about the sample. For example, we could see that number one, most farmers have different weights, and not only that, the most popular or common weight of household head is 64. Now if you look at 64, we have 6 observations, 6 household head has 64 kg. So that is the most occurred value. So this is an example of ungrouped frequency distribution, and the display is called frequency table. Note that the total should be equals to the number of households, which is 35. Of course, if you count all these number of farmers having such weight, you will discover that we have 35 observation. So now, before we continue from here, I need to say this. Now we have just 35 observations here, and you see that we have for the observations we have 18 rows. Now imagine that we have thousands of observations, then it means that we won't be able to present this data using the format that we just use here. Ungrouped presentation of the data will not be reasonable. So therefore we will need to present the data using grouped format. Now, but before I discuss the grouped distribution, I mentioned frequency the other time, which I assume or I believe you should know. But nevertheless, what is frequency? The number of farmers having a certain, as in this example now, a certain weight is called its frequency. So in general, the number of times a particular variable or individual occur or is called is frequency. So this sometimes we use FREQ to represent that column. So And as we've seen in the table, as we've presented in that example. Now let's discuss, as I've mentioned, grouped distribution. So, which is very important if observation is, we have larger observation that cannot be presented using ungrouped format. So, and to present it in a group format means that we grouped the observation. So, and it will be more convenient to do this so that the observations, I mean, the table will be easily presentable, and we can view it in a summarizing way. Now, for example, in that data that I've just discussed, we can present it in such a way that we have 52 to 53, 54 to 55, such that in each class or group we have 2 observations. So then till we have 56 to 57, and so on and so forth. Now, if we do that, then the table will become what we have here, such that we have the group, which we can refer to as class interval, as 52 to 55, for example, which means we have how many observations in that class? We have 52, we have 53, 54, and 55. That is 4 observations in each group. So, and from 52 to 55, how many counts do we have? We have 3 observations in that class. Now, I want to believe that you know how to formulate the tally. Tally is just to help us get the accurate result without missing any observation out. So I won't discuss much on that. I want to believe that you've done that in secondary school, and you are familiar with that. So now, so the second class, we have 56 to 59, and also we have 3 observations there. Then in the third class, we have 60 to 63, and in that we have 9 observations. Then in the next one, we have 64 to 67, and we have also 9 observations there. The next one is 68 to 71. We have 8 observations there. The next one is 72 to 75. Then we have 2 observations there. Then we have 76 to 79, where we have 1 observation. If you add up this, you will discover that we have 35 observations. Now, the question is this: how can we formulate the class interval in such a way that, or is it a guesswork that an individual will just sit down and guess? Now, before I answer that question, let's look at some of the terms that we are going to use here and get ourselves familiar with those terms. Also, the class boundary, I'll discuss that also very soon in the course of the lecture, which you need to stay attentive so that you'll be able to grab and understand everything in details. Now, let's look at the definition of some terms. Number 1 is class limit. These are the end number of each class. Take, for example, a class has 52 to 55. So the class limits here are 52 and 55. Those are the numbers that begins and end that class. So the number that begins the class, which is 52, is referred to as the lower class limit, and the one that ends, which is 55, is referred to as upper class limit. So that takes care of upper and lower class limit explanation. Then the next one is the class boundary. These numbers are used to separate the classes so that there are no gaps in the frequency distribution. So the gaps are due to the limits. It can be obtained as follow. Now, this aspect I want you to pay attention, because I will review uh, important uh, clue that are not written in the lecture material, so that you'll be able to understand better. Now, in this case, what we do is, for the lower class limits, for the class boundary, we subtract 0.5 from 52 to get 51.5, and we add 0.5 to the upper class limit, which is 55 plus 0.5, which gives us 55.5. So, and that is the class boundary for the first class. You will see that we have 51.5 to 55.5 for the class boundary. What we simply did was to subtract 0.5 from lower class interval and add 0.5 to the upper class interval. So that gives us 55.5 and to 51.5 to 55.5. Now, the question where I'm going is this. So, what if you have the class interval, such as take for example, such as probably you have the class interval to be let's say 52.1, and that's to say 50. Oh, let me put it this way. Let's say you have 1, or you have 0.5 to 0.9. Then you have another class to be 1.0 to 1.5, and you have another class from, say, no, that will be, say, 1.4. Then you have another class to be 1.5, say, to 1.9. Let me stop there. Now, suppose that this is what you have as the class interval, and you have these three classes, 0.5 to 0.9, 1.0 to 1.4, 1.5 to 1.9. Now, what are you going to have as the class boundary? If this is your class interval, let me call it class interval, that is C high, to summarize, abbreviate, to abbreviate that, class interval C high. And what are you going to have as class boundary? Say CB. Now, what are you going to have? Will you say that you are to subtract 0.5 from the lower and add 0.5 to the upper class boundary? No. Now, when you look at the first one that we have 52 to 53, 52 to 55. When you look at the class interval here, 52 to 55. Now, after 55, which number follows? 56. And that gives you idea of, this is count of 1. Count of 1. yeah, count of 1. That is, after 56 is after 55 is 56, which is count of 1. Now in this case, after 0.9 is 1.0, after 1.4 is 1.5. That is count of what? This is not count of 1, but is count of 0.1. So after 0.5, the number that follow will be 0.6, 0.7, 0.8, 0.9. Then after 0.9, you have 1.0, 1.2, 1.1, 1.2, 1.3, 1.4, which is count of 0.1. Now it is that 0.1 that you divide by 2. 0.1 divided by 2, that will be 0.05. Now it is that 0.05 you will subtract from the lower class interval and add 0.05 to the upper class limit. Now lower class limit, and subtract that 0.05 from lower class limit and add 0.05 to the upper class limits, and that will give you 0.45 and to 0.95. Then the next class will be the next one will be 1.0 minus 0.05. That will give you 0.95 and to 1.4 plus 0.05. That will be 1.45. Then the last class now will be 1.45 to 1.95. So that is how to obtain the class boundary. Many students thought or conclude that once we say that you subtract 0.5 from the lower class limit and to get 51.5, and you add 0.5 to the upper class limit to get 55.5, and that is the method to obtain the class boundary. They thought that is the method at all time. No, you look at the value you have, the data you have is the count of what? For example, if you have observation that is count of 10, count of 100, and so on and so forth. So it is the count of whatever it is. That value is what you divide by 2. Subtract half of that from lower class limit and add it to the upper class limit to obtain your class boundary. So that is the method. And when you look at this, you discover that you have the value that ends the first class is the value that begins the second class. If you had done it in such a way that you subtract 0.5 from the lower class limits and you add 0.5 to this, you will get wrong class boundary. Please take note of that. Now, if you are learning that for the first time, if you are hearing that for the first time, please let me know in the comment section. Now, the next thing to discuss here is the class size. Some literatures we refer to it as class width. So it's the same thing we are talking about. This is the difference between the upper and the lower class boundary. So to get the class size, you find the difference between the lower and upper class boundary. That will give you the class size. Take for example from this, when you find the difference between lower and upper class boundary, 55.5 minus 54.5 will give you 4. Any of the classes you choose will give you 4. That's, for example, 79.5 minus 74.5 will give you 4. So the difference between the upper class boundary and the lower class boundary will give you the class size. Then the next is the class mark or midpoint. This is the midpoint of the class interval and is defined as the lower class limit plus upper class limit divided by 2. It's just the average of the class limits. So, and that is about that. Now, maybe I will also give you a clue on this also later. That's when we talk about the class size. Take for example, take for example, take for example, let's come here. Let's say, okay, let me try to clear up this small so that it will not be interfering. Now, say, take for example, you want to obtain the class okay, midpoint for this table, and like I said, is the average of lower class limits and the upper class limit. That is 55 plus 52 divided by 2. So if you find this 55 plus 52, that will give you 107 and 107. Then you divide that by 2, you get 53.5. You get 53.5. So which means the class mark, let's call it X in this case, you have the class mark for the first class will be 53.5. Now, once you have that for the first class, now, and you have your class size, which is 4, then to obtain the second one, you can just use the short method saying 53.4.5 rather, 53.5 plus 4. That's the class size. That will give you 57.5. Then the next, for the next class also will be that plus 4. That will be 57. That will be plus 4. That will be 61.5, and so on and so forth. If you continue, the next class will be that's 61.5 plus 4. That's 65.5. Then for the next class also will be, that's 65.5 plus 4. That will be 69.5. Then that's also plus 4. That will be 73.5. Then for the next class also will be plus 4 of that will be 77.5. You can confirm that and see, and if that is confirmed, if you confirm that, type confirm in the comment section. So, and for example, the last observation, which is 76, which is 76 plus 79, that will give you 150. That is 155. 155. Then divided by 2 should give you 77. I hope you understand that. I hope you get that. So I need to explain that so that you have a perfect understanding of what we are talking about here. And I hope with that you don't have any confusion about how to obtain all these class interval, class boundary, and all the likes. So thank you. So 77.5 there. That's about that. So that's about the class mark or midpoint. Now, how do we construct frequency distribution? As I've said earlier on, that how do you just guess the class interval? Do you just use any value at will? There is no hard or fast rule for the construction of frequency distribution, but the following procedure may be followed as a kind of uh, uh, a guide to guide you on how to construct it, at least in a standard manner. Number one is to try to use equal interval width, and this is useful for comparative purposes for easier calculation as well. Number two is the number of classes should not be too many or too few. A rough guideline for constructing K classes for a sample data is the integer value of K such that K is equals to where n is the sample size, and this is known as the Stokes rule. So we can make use of the Stokes rule as uh, a guide to help us to construct the number of classes that is expected. So, and if we are to use that for the example mentioned above, take for example, we have say I to represent the class width or the class size. Now, if I is to be the value to be the class size, then the formula for high to obtain high will be the range over divided by the number of classes. Now, if we determine the number of classes we want to use, we can easily construct the class size using this value that high is equals to the range divided by the class size, that the number of classes that we want to have. Now, if we want to use the example above for this formula, let's say that K, which is the classes number of classes that we want to have, is equals to 1 plus 3.322 log n. That is, K is equals to 1 plus 3.322 log n, which is log base 10 natural log n, which is the Stokes rule that we want to use as a guide. Now, then it means that K will be equals to 1 plus 3.322 log 35, and log 35 will give you 1.544. Now, if you simplify that, you have 6.13. Now, what we were taught is that when you have a value like this and you want to approximate it to a whole number, you have, since after the decimal the value you have is less than 5, then you round it off, it will be 6. The answer will be 6, but in this case that slight 0.13 can be costly when you want to construct the frequency table, and I will show you an example of that, in the sense that I will give you an assignment that go ahead and use 6 for this same example, and you tell me in the comment section what your experience is. You tell me in the comment section what your experience is. You will discover that the last value will be lost, and if you confirm that, please let me know in the comment section. Now but in this case we don't want to lose any value. That's why we are approximating it to 7. So we say that that is equals to 7. We are using 7, so just for as example, as I've mentioned. Then I now in this case now will be the range. Range is 76 minus 52, then divided by 7, which we are using now, and that will be 3.43. In also, like I said, that we are using 4. We say that this is equals to approximately equals to 4. So yes, 0.4 should 3.4 should be approximately 3. But in this case, we don't want to lose, as I've mentioned, we don't want to lose any information, so we are approximating it to cover all ground of observations that we have. So note that 6.13 and 3.43 were rounded up to 7 and 4 respectively to preserve all information in the raw data. So as I've mentioned, just to preserve all information in the raw data. So, and with that, you now see that we have 7 classes, and the class what's it called, the class size is 4, and that's what gave us the idea of we are having 4 observations in a class. And by the time you count, we have 1, 2, 3, 4, 5, 6, 7 classes. We have 7 classes. If you had approximated the value to 6, it means that you will stop at 75, 72 to 75, which means 76 will be lost. So 76 will be lost. So to prevent that loss, that's why we round it up irrespective of the value that is after the decimal. Please take note of that. So then that's about that. Other form of frequency distribution, we have relative frequency. So we can as well obtain the relative frequency in this case, as we have in this example. So the relative frequency for the first class will be the frequency of that class divided by the total frequency, which is 35, and multiplied by 100. That will be relative frequency in percentage. Some literatures will obtain the relative frequency not in percentage, so meaning that you can you may not necessarily multiply this by 100, such that the value will be 0.0857 instead of 8.57. So now if you present it in percentage, the total relative frequency in percentage should give you 100, and if you don't present it in percentage, then it should give you 1 at the end of the day. If you don't get that 1, it means that something is wrong somewhere. Then you should go over it again. So let's quickly move to cumulative frequency distribution. Cumulative frequency distribution. So suppose that the data in the first example, as we've discussed, and we are interested in answering questions such as how many household heads weight less than 53 kg, and how many household heads weight are more than 52 kg. The answers to this and other similar questions are best answered through cumulative frequency distribution. Through cumulative frequency distribution. And what that means is that we need to obtain the cumulative frequency distribution. And how do we obtain that? The cumulative frequency will be obtained for each class in the frequency distribution table. Now, for the first class, the frequency of the first class will still remain the cumulative frequency of that class. Then the cumulative frequency of the second class will be the addition of the frequency of the first class and second class. That will be 3 plus 3. That gives us 6. Then the cumulative frequency for the third class will be all the frequencies from the first class, second class to that third class, and that will be 3 plus 3 plus 9. That gives us 15. The same thing for the fourth class. That will be addition of all the frequencies till that level of fourth class. That will be 3 plus 3 plus 9 plus 9. That gives us 24. And that's what you do till you get to the last class. So such that cumulative frequency for the last class will be total sum of the frequency column, which is 35. So, and that is how to obtain the cumulative frequency for the table. So that is how many household heads weight less than 52 kg. So since no interval strictly cover weight less than 52 kg, the answer is 0 household heads weight less than 52 kg. So that is the answer for that one. So there are many other questions that could be answered using this table. We have some questions listed here, that is the number, answers listed here, that is the number of farmers whose weights are less than 52 kg is 0. That is, no farmer has weight less than 52 kg. That then the number of farmers whose weight are less than 56 kg are 3. We have the numbers of farmers whose weights are less than 60 kg is 6. Then the number of farmers whose weights are less than 64 kg are 15. Then the number of farmers whose weights are less than 68 kg is 24. Then the number of farmers whose weights are less than 72 kg is 32. Then the number of farmers whose weights are less than 76 kg is 4. Then the number of farmers whose weights are less than 80 kg is 35. So that is all about that. Let me know if you have any question or observations or clarification you need to make in the comment section, or you send it to the our class group so that it will be attended to either by me or any of my colleagues that are in charge of this course. Thank you. Have a nice day. Enjoy yourself.